So let's review what is climate.
Climate is the weather over time.
Long-term weather. That means what?
Like
Long-term
for example,
trends of?
Temperature, precipitation.
Perfect. Long-term trends of temperature and precipitation. That's the exact definition of climate, overall. So that's why when people say climate change, that's all a lie. Look how cold it is today. What are you referencing when you say look how cold it is today? You're referencing the weather of today. You're not referencing the weather today over 10 years of data.
that's why it's called the Weather Channel.
Correct. So answer people that way. That's why it's called the Weather Channel and not the Climate Channel. Okay. So what actually affects climate? There's a lot of factors that determine the climate of this world. What are they?
Distance from the sun.
Distance from the sun. Actually, it's not.
It's solar activity.
It's solar activity. Distance from the, look at the picture.
Tilt.
Yes. Distance from where? Equator. So that means what else affects climate? Yes, air circulation patterns, location, which is basically your geography, ocean currents or circulation, and one more. What's that picture down there? Correct. Obviously, there's something missing here that affects climate. What is it? And it should be in this page. I can't say humans. Where are you linking humans to? No?
Deforestation.
What? No? Well, you're kind of getting there.
Greenhouse gas.
There you go. Write it down. Greenhouse gases. I'm just going to put GG, and those are greenhouse gases. Greenhouse gases affect climate, and I didn't add them to this page. I want you to because it should be, because I have a whole topic on greenhouse gases. Because obviously the greenhouse gases have affected our climate positively and negatively. So we're going to talk about it. So over the past 4.7 billion years, the climate has been altered by volcanic emissions. We know this. The birth of Earth formed our atmosphere, okay? And atmosphere affects climate. So there it is. Changes in solar input. Again, we're talking about things that affected climate. Movement of the continents caused by what? Plate tectonics, or the shifting of the plates. How do they shift?
Convergent.
Coming together. Divergent, moving apart. Parallel, transform, faults, okay? And meteors impacted Earth's atmosphere, or they came through and impacted our climate. Over the past 900,000 years, you've had these periods of glacial and interglacial. That's what they call it. So you're kind of like freezing or in between. And here is what we call the Ice Age, and in between an Ice Age. And I showed you this in the beginning of the year, this picture of Pangea and Earth's continents, and we talked about how the fact that we're still kind of shifting and there could be some movements. Here's what I was, no more talk of food. Here's what I was just saying, and this is actually from your book. There's a scientific consensus that Earth's atmosphere is warming rapidly, mostly because of human activities, and this will lead to significant climate change during the century. And then I kind of put a couple of graphs here of the past 10,000, 1,000, and 100 years. And do you see, what do you see? What's the pattern you see if I show you this graph? Raise your hand if you could tell me. Of all of them, what do you see? Except maybe the bottom.
Okay, so the first one up there's like differences in the temperatures.
So you're constantly seeing what?
Fluctuating.
Fluctuation. Perfect word, because that is the answer to describing Earth's climate. You see a fluctuating patterns of highs and lows. But if you look at the past 100 years, what do you see? It keeps getting higher and higher. You still see a high and a low, but the high is higher than the normal highs from the past. Okay? And we're going to focus a lot on that portion of the graph. So how do we know, and these are where the debates begin. So if you were gonna debate that there's been extreme changes in our climate, and who could give me some answers? Fossils, okay? The what?
The melting.
It has to do with glaciers. There's actually these cores inside glaciers, and if I zoom into the picture, you'll see that they're extracting them right there in that picture to the right. That's what an ice core looks like.
Is that plankton?
That is plankton. So remains of plankton, insects, and bat dung. And obviously temperatures taken since 1861, which is where they can actually say they were monitoring temperatures accurately. You get what I'm saying? So anything besides 1861, we have to use fossils or these ice cores in order to determine what levels of temperature were. So our climate depends on greenhouse gases. Greenhouse gases affect the climate, but the climate depends on them. Why? It traps heat. Without greenhouse gases, Earth would be inhabitable. We would not be able to live here because it would be too cold. So the greenhouse gases actually helped life be sustainable on Earth. Now, our excessive pouring out of these gases is where the topic comes into play. Did we affect climate by pouring all these gases into the atmosphere that weren't there before? And that has to be something you're going to have to determine on your own. We know for a fact that with industrialization, in order to move forward, we removed a lot of things from beneath Earth that were not part of the natural cycle, and we put them into the cycle. So it's a no-brainer. But remember that without these gases, we couldn't live on Earth. So here's how these gases work. UV rays, write the word UV. I should make this a little bit bigger so you can actually see what I'm writing. And I'm going to change the color because I'm sick of the purple. UV rays come down from the sun. Where did I just travel through? Let's do it in order. What's this? Exosphere or ionosphere, then comes the thermosphere, then comes mesosphere, stratosphere, and troposphere, which is that big chunk you're seeing closest to Earth. So the UV rays come down through the atmosphere. We know the sun is outside of Earth, that's why our energy is an open system. And when they're reflected back as heat. So we're changing them now to infrared rays. UV rays come down, infrared rays reflect out. Where are they going? Up where? Through the troposphere, stratosphere, mesosphere, thermosphere. However, in our troposphere, so I'm going to draw a ray right here. What ray is that? UV. In our troposphere, we have greenhouse gases, right here. That one happens to be water vapor. So the infrared, when it bounces up, gets what? Re-radiated back down to Earth, causing warming, right here.
Wait, what bounces back?
I'm going to repeat that.
The infrared.
And I'm actually going to change this. I'm going to make my UV rays, I'm going to keep them blue, and I'm going to change my infrared rays to green. Can you see the difference?
Why don't you change it to red?
Okay, I'll change them to red.
It's like the same color.
In the courtyard.
I'm going to explain it again with color-coded rays. So the sun rays come down as what? UV rays. Whoops. So my UV rays are going to be blue, and that's not blue.
It's okay.
Blue rays come down, and those are UV. UV are blue. When they hit Earth and travel through the atmosphere, they go up as what? Infrared rays are red. Okay, in this diagram, that's just to make the diagram a little bit easier to understand. In our atmosphere, we have greenhouse gases. In this case, we see right here water vapor, H2O, which is our #1 heat trapping gas. So this ray, I'm gonna draw right here.
This right here. H2O.
Yep, I'm gonna teach you that. Don't even worry about that now. Comes down, which ray is this? UV. What ray is this? Infrared is supposed to go out into the atmosphere, out of Earth, and back into space, but this greenhouse gas pushes it back down to Earth.
So the water.
So the greenhouse gases absorb and re-radiate heat, causing the heat to hit Earth, as I just exposed right here.